I can't think of a better way to kick off this series, though, than with an A-list panel talking about a truly potentially game-changing technology. So with that, I'll turn it over to EPRI Senior VP and Chief Nuclear Officer, Neil Wilmshurst. Neil, the floor is yours.
Okay, hey, thank you, Will, and welcome to everyone. Thank you for joining me today. The driver for this is really the thought we're all getting ready for COP coming up in Dubai in a few months. And EPRI is working with our global partners, getting ready to make sure we're synchronized, coordinated, and our message is being heard. So the thought was that today we'd cover nuclear. Nuclear has been quiet historically at COP meetings, but the last couple of COP meetings, nuclear has become more and more visible, and we perceive that the upcoming COP meeting in Dubai, nuclear is going to have a big presence. Nuclear is not easy. You know, you've only got to look at countries like the UAE, how successful they've been, but what they had to do to get there. So there's lots of lessons for people who are trying to fulfill that ambition to deploy nuclear. And it's really important at this moment in time that if nuclear is going to be part of the solution, nuclear needs to understand not just the opportunities, but the challenges and what is being done and what can be done to overcome those challenges. And as a backdrop to this, something which may come up during the conversation, EPRI and our friends at NEI recently published a roadmap for addressing the technical challenges going forward deploying new reactors in the USA. And we're working with our friends at WNA and NEA to actually translate that into a more global effort as well. So the context of this conversation is really to discuss the opportunity, but also to keep our feet on the ground around the challenges and actually start understanding what we can all do to work together to address those challenges. And as Will teed up, I'm really happy to have a panel here of three of the organizations which EPRI works very closely with. We have Jonathan Cobb, who's a Senior VP of Communications at the World Nuclear Association based in London. Jonathan really brings a wealth of experience and knowledge from the scope that WNA have across the globe, talking to their members around these issues we're going to talk about today. Then we have my good friend Diane Cameron from OECD NEA based in Paris. Diane, you may win having the best location of the panel because I think we all envy you being in Paris. Diane is the head of nuclear technology development and economics, which is quite a mouthful, at OECD NEA. And OECD NEA is really another one of those global players in this nuclear infrastructure with a great perspective on, again, the opportunities and the challenges. And then finally, but definitely not least, Doug True, another good friend of EPRI, Senior VP and CNO at the Nuclear Energy Institute based in DC. And Doug is really well connected with what's happening around the discussion for new nuclear deployment within the USA. And as I mentioned, was closely involved in the roadmap work, which we've recently published. So welcome to everyone. And I see people keep joining. It's always good when your screen in front of you flashes as more people are showing up. So what I'm going to do, I'm going to start with a question for each of the panelists. Same question, each of the panelists in turn. We'll start with Diane, then Jonathan, then to Doug. And the question is basically within the context of your organization and what you're seeing and what you're anticipating, what do you think about how will advanced nuclear contribute to a low carbon future? And what are you seeing around demand for this technology? So starting with you, Jonathan. Diane.
Okay, thank you, Neil, for the great introduction and for convening this discussion at this point in time. It's sort of the beginning of the lead up, the ramp up to COP28 in Dubai, which is going to be a really important COP for nuclear, really important COP for climate more broadly. So to your question, the role that advanced nuclear has to play, maybe I'll couch that within really a quick comment about the role that nuclear has to play, because not only do we need to see all non-emitting technologies deployed in order for countries to have any realistic pathway to net zero, we need within nuclear energy, nuclear to play every role that it can play. And so we always want to start at the NEA by emphasizing that that can only be achieved through a combination of life refurbishment and long-term operation of existing large-scale assets. That's the first priority. The next priority is new builds. And new builds, we need both large and small, and we need technologies that are ready to deploy now, and we're also going to need advanced reactor technologies to meet new types of demands and applications. So that means nuclear for power generation and also advanced nuclear for heat applications. So our analysis at the NEA suggests that nuclear should triple from current installed footprint around the world to reach nearly 1,200 gigawatts of global installed nuclear capacity by 2050 in order to play the role that it needs to play, that nuclear needs to play in pathways to net zero. And so that really requires power applications, but it requires advanced reactors to be deployed as quickly as possible to reach a range of new applications. And we do see the demand for that. We see private sector consumers of heat like heavy industry. We see the demand for hydrogen production. We see district heat or district energy needs making their own commitments to decarbonize, and really having very few options to get there without non-emitting high temperature sources of heat. And that's where advanced nuclear is going to play a role.
Okay, thank you very much for that. Same question to you, Jonathan, about what are you, WNA, seeing around the role of nuclear? And just to help the discussion and some of the participants, OECD membership, NEA membership, WNA membership is different. OECD membership tends to be more developed countries, more developed economies, whereas WNA may have connectivity to some countries which aren't members of OECD NEA.
That's right. Just to touch on that point, of course, one difference again, another difference is that the membership of World Nuclear Association is of individual companies, and they are companies from the industry around the world in many countries around the world. So yes, we have perhaps a little broader geographical range, but also a different type of membership. To the question, I think the main thing I note is that there is an incredible amount of activity at the moment on small modular reactors around the world. Just looking at news stories of the last week, you'll see announcements of new collaborations, new government initiatives, and we may come on to those later on in the discussion. But there's a lot of activity at the moment, but it's all kind of at the starting gate. So if you look back at the last few countries that have become new nuclear countries, so looking at the UAE, which will host COP28, but looking ahead at Egypt and Turkey, which are developing their first nuclear power plants, they're doing it with large-scale reactors. So there is a thing, I think, a need now to move forward from the lot of activity there is on SMRs to actually getting into deployment. Because if we are going to reach the goals of COP28 and the climate change process, and if we are going to reach that target that Diane mentioned, I think it's a very good basis and a good thing to aim for the industry, a tripling of nuclear generation. It's going to need decarbonization, not only of electricity, where there are other options available. Nuclear would be working with other options, but it's the harder to abate sectors, as Diane said, which really are going to be the ones which are going to need nuclear perhaps more specifically than just electricity generation. And I think a key thing there is, it's kind of weird. What marks out the difference between SMRs and conventional large-scale reactors? We focus on the S, the small. The smallness of the reactors is actually one of the least interesting and least applicable things in terms of the potential for them to get into these hard to abate sectors. It's the diversity of the different technologies that are being developed as SMRs, which provides them with this diversity of applications. And I think that's going to be absolutely crucial for getting global all economy decarbonisation.
Thank you, Jonathan. Doug True. So, Doug, with your focus on America, and I look at all the different developers talking about different technologies in the US to kind of leverage on Jonathan's point. What are you seeing in the US? Because I know things are changing also on a monthly basis.
Yeah, thanks for having me, Neil. This is a really prescient subject that is so dynamic right now in the United States that it's almost hard to articulate. We surveyed last year our U.S. utility members who represent about half of the U.S. electricity generation right now. And they see about a need for about a doubling of the U.S. electricity generation from nuclear, which would be about 100 gigawatts. That doesn't count, obviously, other utilities that might consider it, nor the non-electricity generation like the industrial use and heat uses that Dan and Jonathan have talked about. I think the Department of Energy just came out with a study that says that we need to triple in the United States. So I think everyone sees this need. Our Congress has taken steps to implement policies that will support that. And in a quite divided United States Congress, about the only thing our Congress can really agree on is that they all like nuclear. And that presents a great opportunity. I think we have a lot of innovation going on in the United States, a lot of different types and sizes and shapes of SMRs being deployed. I also agree that I think large reactors are going to be needed in the long run to gain the scale we need. And I agree with Jonathan's point about SMRs really providing a diverse portfolio to support different needs. I also want to point out that the S in SMR has been applied to small, but it's really about simple, which makes them less complex to build, easier to build, faster to build. And that simplicity is going to serve us well as we try to scale up.
Right, thank you. And we said we wouldn't take questions, but I'm actually reading the chat as we go. There's a great point being made. It's not so much a question. You know, the US Navy and the UK Navy, which I used to serve in, been operating SMRs for a long time. So kind of this doesn't necessarily need to be looked at like a new challenging technology if you're talking about LWR SMRs. So moving this forward, and again, trying to narrow the conversation down from nuclear in general down to SMRs in particular, which is the topic of this panel. So Jonathan, when you at WNA look globally, where are you seeing the strongest interest and progress? And what is a WNA perspective on the gaps and the challenges? You know, we're all nuke, so we're all positive about the opportunity. But as I said when I teed it off, we do to an extent need to be real and keep our feet on the ground and recognize the challenges so that we can address them.
Yes, I think we can see the areas around the world where nuclear SMRs are being developed is often in the places where there's already a well-established nuclear industry. So yeah, we want a break from discussing all nuclear, but it has to be recognized that they're often tied together. So in the last week, I think we've seen the announcement in the United Kingdom, the next steps with developing what they are calling Great British Nuclear. Yeah. It's basically a competition going ahead over the next few months to select which of all the different international variations of SMRs there are, which would be most applicable to the needs of the UK, with the idea of those being deployed by the early 2030s. So that is a major step forward in the UK, but the same announcement is bracketed with the idea of further deployment of large-scale reactors. There has been an expansion of the agreement between France and India. So India is now looking to potentially develop SMRs with the assistance of France, but that's part of an agreement alongside further development of large-scale reactors. And Poland is a really interesting example, I think. Poland and Korea have announced some agreements again in the last week, looking at the deployment of SMRs. But again, as a country that's looking to deploy its first nuclear reactors, it's looking at both large and small scale reactors. So I think we can really see a pattern around the world of countries that are looking to develop SMRs, but they're often doing that alongside deployment of LWRs as well. So they're certainly not exclusive to each other. It's a case of all options being available, and that also means all options of nuclear technology.
Thank you, Jonathan. And one observation that I think we need to get on the table as we go forward, you talk about people discussing deploying SMRs, discussing potentially deploying SMRs. One of the challenges I think we face is the designs for these reactors that are being talked about are in completely a whole range of positions. Some of them are still conceptual, some of them are close to construction. That is one of the challenges we have, I believe, is the demand curve stimulating the development curve. And we may be in a critical moment in time where demand needs to ramp up in order to stimulate that continued development. So that is, in some instances, the elephant in the room, supply and demand. So moving on to another question for Diane. This is a global effort. This is more than one country can do, more than one organization can do. What do you at NEA and you with your experience before NEA, what do you think is the role of international collaboration and knowledge sharing for SMRs? And expanding that to what are the problems and challenges to information sharing?
So those are very big questions. The way that we think about the conditions for success, because what you're really asking about are what are the conditions for success with SMRs and AMRs, advanced modular reactors. And part of the condition for success, coming back to your comment just about supply and demand, is that there needs to be a global market in order to support the supply side. The demand has to be there to support the supply side. And we see the demand, at least in theory, globally. We see the demand, the need to replace 2 terawatts of global installed coal capacity. Not all of that is going to be replaced with nuclear, but some of it can and should. But we also see the need to replace natural gas cogeneration, combined heat and power. And we see the need to replace bunker fuel for marine merchant shipping, the need to replace diesel for off-grid communities and off-grid mining and resource extraction. So the demand, the footprint for the demand, at least in theory, is truly global. And then we have to tackle how much of that is truly accessible and what would it take for nuclear to actually supply that demand, to break into those new markets, many of which are not in countries that have nuclear sectors today. And when we really look at it, many of the challenges are far beyond technical feasibility. As was noted in the chat, countries have been operating nuclear icebreakers and nuclear submarines for many decades. We have experience with small nuclear. We have certainly lab scale experience with many of the so-called Generation 4 or advanced reactor concepts, be they molten salt concepts or high temperature concepts. And so this is really about bringing things together in a new way to meet these new markets. And so the technical challenges, some still exist, but some of the bigger challenges pertain to market access, regulatory collaboration, licensing timelines. If you license in one jurisdiction, will that be recognized in other jurisdictions? How do you open up these global markets by making the economies of multiples extend across international boundaries? And there needs to be fuel availability in the markets that need to be served. There needs to be a plan for the back end. There needs to be supply chain. Talent needs to be developed, not only in the exporting countries, but also in the importing countries. So we spend a lot of time thinking about these enabling conditions, these conditions for success that go far beyond just the technical design of a reactor. That's what's going to allow us to unlock these global markets.
Yeah, I think that's a great kind of tee up to the next question. It sets up the probably another line we may go down talking about supply chain. And in my view, I look at supply chain as more than big pieces of metal. It's people. It's actually how you develop a regulator and everything else. So maybe start thinking about that one. I think if we've got time, we should go down that path. But staying on the technical side, Doug, I teed it up earlier, NEI and EPRI work very well together producing this advanced reactor roadmap. Do you want to talk about the roadmap, what the response has been, and how you see that being used going forward to help this SMR deployment?
Yeah, I think this is a really significant document and one that was really important for EPRI and NEI to collaborate on and produce. It outlines objectively the challenges that are in front of us, but then lays a path for how to navigate that and the actions that are going to be necessary to get through those obstacles. And I think that it makes the case that, yeah, there's work to be done here, but we can see a path to be able to achieve this deployment. One of the things, nuclear takes some time to deploy. It's a large construction project and licensing timelines are involved. That gives us time. And if we start working now on this, we can make progress and be in a position to those obstacles like supply chain, workforce, regulatory, are worked through. If we wait, it's going to be difficult. And I think that the reception of this roadmap has been really strong by policymakers, by industry contributors, by regulators, that it lays out that we need to get moving on these actions now, and I think provides a nice framework for us to evolve over time. It's today's picture of what's needed. It'll be a living document that'll need to be updated as we make progress or identify new challenges. But I think it really sets us in a good place to head down the path that we've all been describing here, at least in the US. And I know in North America, excuse me, because we covered both Canada and the US in this. And I'm really glad to hear you're working on a global one, because there are a lot of connections globally.
Yeah, I think that's kind of the point in the background here. There's so much needs to be done. No one organization alone can do it. And as I talk to people about any part of the energy transition, be it renewables, be it carbon capture and storage, nuclear, whatever, there is that point out there. No one country, no one organization can do it alone. They need to learn from other people's mistakes. So a wise man once told me, you learn more from doing things wrong than from doing things right. And the secret is finding someone who did something wrong and learn from them before you do it. So I always bear that at heart. So before we go down, just to give you a warning, my head is heading towards supply chain. But one of the issues, again, we're all on the panelists here, we're nukes, so we like nuclear and we tend not to think about this. But for Jonathan, what are you at WNA seeing around public perception of nuclear, and what can be done to alleviate those concerns around SMRs? And we'll maybe see if that drifts to NEI and NEA. But I thought I'd start with you, Jonathan, because of the WNA role.
Yeah, it's really interesting being in the UK, WNA, World Nuclear Association, but we were quite close to the UK Great British Nuclear launch yesterday, and it's not so much public perception as media perception. For as much as people wanted to talk about, from the nuclear side, wanted to talk about what SMRs were, what the applications were, the one thing that came through from so many of the journalists was, well, you have a problem with getting nuclear plants sited. So if you have 8 times as many plants, because they're smaller plants, doesn't that mean you've got 8 lots of public opposition to deal with? And so that potentially is a problem if you have lots of new locations where you might be bringing in nuclear plants. If you're looking at bringing them onto industrial sites to providing process heat rather than being located in a fairly remote area providing electricity, on an existing nuclear power generation site. That could be a key thing, just there would be more of these reactors potentially in more locations, and therefore the number of people you'd need to engage with in terms of stakeholder consultation, local community consultation will be so much higher. I think that's going to be one of the key things. The other thing I really would advise against, and I think need to avoid this trap, is any kind of one-upmanship on safety. Nuclear energy is safe. Of all types, it is safe. Some designs of SMRs will have particular characteristics which offer great safety benefits. But that thing about nuclear needs to speak as one. We'll be heard together or we will lose if we're separate. We've got to ensure that we don't try to one-up each other and say, my technology is better than that, because all you do by doing that is make people think that all the other nuclear must be unsafe. And it's just your one example that you're bringing forward as being safer. That must be the one that is safe. You're going to destroy the reputation, and your benefit from being the best of what might not be perceived as a good bunch is going to be detrimental to you. So when we do come to talk about safety, when we do come to talk about acceptance of SMRs, we need to take a really careful step on how we project that, how we talk about what advantages there are with SMRs, characteristics there are with SMRs, not to push down everything else in an attempt to make that point.
That's really good insights. I think the nuclear industry over the past decades has perfected flying under the radar screen. And now we're talking in public, we need to really be conscious about that. So Diane, I know NEA kind of gets into this kind of dialogue at times. Have you got anything you want to add to this?
Yes, I think that there's an enormous amount of momentum around the world for nuclear energy today in a way that hasn't been there for decades. And there's a seriousness to this momentum that wasn't there around the so-called 2010 Renaissance, when the nuclear sector at least was very optimistic that we were headed into a period of considerable new build. And I think what's forcing that is the confluence of the climate crisis, which is coming into sharp focus around the world, the reality of how short the timelines are for action, compounded by an energy security crisis, and also, in many parts of the world, a desire to alleviate energy poverty, and to foster economic development. And when these strategic priorities become very real and very tangible in people's lives, it forces, the positive thing about crisis is it forces a very adult and serious conversation about what the real options are in front of us. And so I think that the conversation about nuclear with the public and with communities in some ways is becoming more real. And one of the things that has happened is that now that the timelines are quite short for decarbonization, it immediately starts to push aside some of what were sort of fantasy-based aspirational goals for how we might do this, that we might do this with technologies that don't yet exist, that we might do this with, but we have to act now, and therefore we have to act with technologies that we have now. We must continue to invest in innovation in all of these wonderful breakthrough technologies, be it fusion, be it advanced nuclear, be it smart grids, storage. This is all needed, but we also need to act today with the technologies we have available to us. And so I think what we're seeing in some of our member countries and different parts of the world is a change in the public facing conversation. And I think that's related to climate and energy crises.
Thank you for that. You bring up a lot of good points. I often say to people, the final investment decisions for the infrastructure we're going to have in 2050 are being made in the next 5 years. And if you're going to make those decisions in the next 5 years, you've got to invest in technology And that doesn't mean you should stop innovating for new technology for later on, but people need to double down on the technologies we know, whatever they may be. And nuclear is not the only answer, it's part of the answer, we all accept that. But this actually puts a tremendous pressure on the nuclear industry to really deliver, and actually puts a pressure on the industry to deal with that kind of public perception part and everything else. So Doug, I know NEI's been very active in the US around this whole perception of nuclear, communication of nuclear. Have you got any kind of different perspectives from what you've heard, or maybe additive to what other people have said?
No, I agree with what's been said. I think there was a really significant survey that was completed recently where like 12,000 people were interviewed globally about their attitudes towards nuclear. And it came out with some really interesting insights that, and they surveyed people in Germany and Japan and Poland, United States, Canada, all around the world. In every country, the overall attitude was positive towards nuclear. A lot of what we hear about and being against nuclear is, I don't think my neighbor will like it. But when you actually interview people and talk to them, it's really people genuinely are more interested. There's a group in the middle that's less maybe convinced, but they're quite convincible if you have a good conversation with them about the realities of nuclear and what it provides, what it, its safety and its attributes. And there's a hardcore set of folks that are not going to ever probably change their mind. But it really changes your picture of what we're dealing with to understand how significantly the skew is positive towards nuclear. And a lot of it gets to what Diane says. People are realizing that we really need to move forward with decarbonization. And nuclear has been here all along. They probably ignored it most of their lives. But it can really be part of the solution.
Okay, thank you, Doug. Hey, so we've heard so far that SMRs exist. Nuclear has a big role, or needs to have a big role in the energy transition. That the global perception of nuclear appears to be changing as people are realizing that nuclear works and that nuclear is a technology that exists. So there's kind of an expectation here that nuclear is going to deliver. And I think the heat wave that we're all suffering, and Diane, it's good to see you in a room with air conditioning. I know you weren't in one with air conditioning yesterday when I spoke to you. So the world is now being focused with this heat wave on climate change. So I think the demand and the expectation of nuclear can only be going up. And as I started at the beginning of this, we need to harness that optimism and that enthusiasm. There's never been a more exciting time to be in the electric industry, and certainly more exciting time to be in the nuclear industry. But part of that is keeping our feet on the ground and recognizing the challenges and what we need to do. So for each of you in turn, I'll probably start with, might as well keep the flow going. I'll start with you, Jonathan. We've had this excitement before. 20 years ago, 10 years ago, we were going to build fleets of large reactors. We're now talking about hundreds of SMRs. And this could be the start of a supply chain kind of conversation. What is different this time, and what do we need to do different?
I think the difference this time is partly the world we're in. So in other words, that thing about creating demand that I think Diane mentioned and others have mentioned, that there is this increasing demand. We've had another 10 years of not decarbonizing with other options. And it's got to very close to being too late, full stop. But it's got to the point now where governments are looking at the solutions they've tried and seeing they're not making the progress. And so that is creating the demand for nuclear, and they are looking again at all the options. They're appreciating that it isn't just going to be about decarbonizing electricity, and that's creating the demand. And so, yes, now that we're being looked at, we have to deliver. And I think there's going to be major changes in the way that supply chains work, particularly if we move into the vision, if you like, for SMRs, which is factory production. So you're going away from where you'd think about the supply chain and looking at supplying the components for a reactor at a major project in a country. And you have the whole issue of having local and national companies getting a share of the manufacturing, building up those supply chain skills so that they are able to participate in this one national project. We're moving now to factory production. So we need to think of the supply chain as organizations and companies bringing components to a manufacturing factory, and that I think is going to change things, quite radically in the way that the supply chain is structured. And with everything that is new that the nuclear industry has to do, that does create a barrier, a hurdle that has to be overcome. The easiest thing that we can do is carry on doing what we're doing, getting innovation, changing what we build. I think is something that's difficult, and that is why some of the more smaller versions of conventional technology may be the way in which SMRs can get that foothold, because we have one real SMR under construction at the moment in the world, in China, and everything else is getting there, and it should be happening in the next 5 years, but it needs to get out of the starting gate. So I think that's one thing for us on the supply chain.
Okay, and there's an element of, as an industry, we've been guilty in many places of over-promising and over-delivering, and not recognizing the first-of-a-kind costs, the challenges of first deployment, and also going with proven technology doesn't mean you can't innovate within that proven technology.
Yeah, if I can, so just one more quick point on that, which is that although we're focused on the need to rapidly decarbonize, and people saying we need to achieve this in the next 10 years, we need to start really making dramatic reductions. And so that's sometimes a barrier that's placed towards nuclear energy because of the longer construction times there have been. I think we need to consider and bear in mind that we don't stop building generation, we don't stop building energy production facilities in 2050 if we hit the zero emission target. It will continue beyond then. I mean, a fundamental thing is that the lifetime expected for solar panels and wind turbines at the moment is something like 20 to 30 years. So basically, a lot of the wind and solar generation plant that is operating today will not be contributing to net zero in 2050 because it will have shut down by then. That, of course, isn't something that's true of nuclear energy, where we're looking at 60 or 80-year lifetimes. But yes, on that issue of promise, we can try to be part of that first wave of decarbonisation, but we should also be looking at what nuclear can do beyond 2050 as part of an ongoing decarbonised economy.
That's a really good point about that kind of taking credit for that kind of nth of a kind deployment out into the future. And Doug, I know you and NEI have done a lot around this, around trying to get those fast followers, getting to nth of a kind as fast as we can. What are you seeing that needs to be done different this time?
Well, I think that there are a lot of factors that go into this. What we see right now is there's almost an uncountable line of people to be number two. And so the challenge is how to get past number one and do that in a way that demonstrates that these technologies can move forward. Part of our problem in the West is that we have stopped building nuclear in most of our countries and haven't built it for many decades. We're just finishing some plants here that suffered from the fact we didn't have that experience. Countries like Russia and South Korea that have continued to build have demonstrated you can build nuclear reliably. So the compounding factor that takes us into supply chain is if everybody waits to be number two, then you get this hockey stick effect of demand where we go from zero or near zero to infinite in a very short period of time, and supply chains just don't work that way. So the efforts that we've been undertaking is how do we establish a way to have a first mover and followed by fast followers that are actually in parallel, not waiting for the first one to be done before the second one begins, and give the visibility to customers on what the risks are, how they're being mitigated, how they're being retired, so that they can move forward with confidence. I think that's likely going to take the form of some form of consortium or otherwise to where customers collaborate together to get a batch of plants off the ground. If you do that, let's say we take 5 or 6 of the initial model of a particular technology and deploy it that way, it gives the supply chain some assurance that there's a real demand signal there. And that assurance to the supply chain allows them to begin to ramp up sooner and not wait until after that first one has been completed and the next one's been sold. So how we orchestrate this fast follower concept, as we're calling it, is really going to be key to being able to both accelerate the rate at which we deploy and bring the supply chain workforce and other activities along by creating that clear actual demand signal, not just a potential demand signal, but an actual demand signal early on.
Thanks, Doug. And Diane, really same question to you, kind of what do we do different this time? And maybe thinking about NEA's kind of role in the world. Can you touch on regulation and regulators? Is there a need for change there?
Yes, but if it's okay with you, I'd like to tease out a little bit more of this broader supply chain question first.
Absolutely.
All right. So really pulling on some of the threads that that Doug and Jonathan have already set out, especially if we think about the more holistic concept of supply chain that you defined at the outset, Neil, where you think about supply chain is not just about production of big pieces of metal and machinery, it's also about the people, and it's about the approvals processes like the licensing processes along the way, everything that takes you from idea to implementation. Then we to hold on to that idea for a minute. And then I want to just acknowledge the magnitude of the challenge, the speed and scale that is needed. And then when we look at the history of nuclear energy, where have we succeeded in the past? France, built more than 50 reactors in less than 15 years. The province of Ontario phased out coal with nuclear and had a similarly successful, in Canada, had a similarly successful nuclear new build program. So the challenges that we're seeing in OECD countries in recent years, it's about not taking a programmatic approach. It's about having these one-off projects that you're repeating first of a kind projects over and over again. If too much time elapses between project 1 and project 2, you lose the learnings, you lose the people, you lose the expertise, you lose practice, you're out of practice. So what does this all mean? I want to set out another piece of context, which is since the successes that OECD countries have had in past decades, there has been an evolution in the context. So the challenges that we're facing today to ramp up nuclear new build are different because we're working in a different policy context. Regulatory requirements have evolved over time. Supply chains have atrophied. There are different expectations around public engagement and transparency and accountability. But also, we have, in many of our countries, divested and privatized our national sectors. They used to be state-run, vertically integrated. They were seen as sort of industrial policy. So we're facing kind of these big challenges in a very different context. Why do I say this? Because as Doug pointed out, he didn't say chicken and egg, but there's a lot of these chicken and egg situations out there where the supply chain won't invest until there's a customer, and the customer won't buy until there's a supply. You see this not just on components, but we see it on fuel and high assay, low enriched uranium in particular. So we've got, and then you actually have kind of the same dynamic with regulators. Regulators can't ramp up their internal human capacity on a particular technology because they don't know which technology is going to be applying, right? Should we be ramping up our expertise as regulators to get ready for molten salts or for sodium or for metal fluid? Like what should we, high temperature gas? What is it that I should be sending my people to get training on? I won't know until they apply. Well, they won't apply until they can estimate the costs, and they can't estimate the costs till they know how long it'll take to, we have a lot of these chicken and egg problems. So We think about it at the international level in terms of strategic partnerships amongst OECD countries. How do we bring countries together? It's strategic partnerships internationally, but also strategic partnerships public-private, because governments have a role to play even where we've privatized the sector. All along the supply chain, so that we can start to get some level of transparency, if not coordination, at least information sharing up and down the supply chain. Across sectors, the demand to the supply sector, so we heavy industry with the nuclear sector, it's going to take a lot of strategic collaboration, a lot of strategic convening to kind of step into this space that we're in. And so that's a big part of what we do at the NEA is we convene public, private, international collaborations and coordination to try and overcome some of these gaps and try to unlock some of these chicken and egg challenges.
Thank you, Diane. You know, that's a great tee up, and Doug, don't relax. You know, one of those examples which is trying to break those barriers is something Doug and I have been engaged with and a number of other people. It's a kind of collaboration across borders between the US and Canada. And you'd think that would be like the easiest thing to do, but we're already finding challenges there. So Doug, I don't know if you want to give some insights into some of the challenges that are being seen and some of the opportunities. Let's be optimistic as well.
Yeah, I mean, I think the U.S., Canada, U.S. NRC and CNSC collaboration is a really important activity because it's two countries that should be able to work together. They have different regulatory philosophies in the way they approach regulation, but common language, common kind of country mores that go along with that. And if there was anywhere that could do this, you'd think it could happen. I think that it's tricky because each regulator has its own sovereign responsibility to make its own decisions. I don't think we'll ever see that completely go away. I think that countries will want to retain their ability to make their own decisions. And while there have been some progress here, I think that the BWRX 300 that OPG is deploying is going to be a really important test of this in North America because the U.S. has a lot of light water reactor technology experience with the fuel and systems and equipment. Canadians have more of the can-do experience. So I think the NRC is trying to help educate across the border. I think also the Canadian regulator has their different way of viewing regulatory processes, more of an IAEA approach, which I think is important for us to work through because if we want to take those technologies to other IAEA countries, we're going to need that IAEA approval. So, and I understand the UK maybe coming into this as well to collaborate, yet another regulator to do that. I think those tests of this are very good steps down this road of trying to reach some level of harmonization or cooperation among the regulators. And we really encourage this test case of the BWRX 300 to demonstrate how that can be done and hope it comes out with a successful cooperation. And I think there's been some examples of success, some examples of more parallel reviews rather than collaborative reviews. And I think it's still a developing relationship.
Yeah, thanks, Doug. And back to my comment about learning from others' experience. If you're out there on this WebEx and thinking about this, monitor what's happening between the US and Canada. What's going well, what could be done different, what they might choose to do different next time. But I'll tell you, OPG and TVA working together is a great example, a great model for people to follow. Yep. So we've got about 10 minutes. So trying to bring this home, and we've covered a lot of territory. You could probably go all day and still be chatting about this. So I want to give each of you a chance to kind of wrap this up. And I'm thinking about where we started, talking about COP28 in Dubai. My prediction is that nuclear is going to really be visible at COP28. And many countries are going to leave COP28 with a ambition to deploy SMRs more kind of firmly set in their plans. So if you assume that hypothesis is correct, and it may not be, if assume it is, in a couple of minutes each, what would your advice be to a new entrant to nuclear thinking about deploying SMRs? Where should they start? Jonathan, you're up first.
They can start with us. They can start with the NEA. They can start with the IAEA. As multinational organizations of different types, we bring together those learnings and those mistakes from around the world for people to learn from and not repeat, as well as the successes. So I think that's one thing. That's the role we have to play. On COP28, just on that, I think if we want people to be going away with those intentions to invest in SMRs, we need to be more than be visible. What we need to do is actually get decisions and support from policymakers. The sideshow of the exhibits that there are and the events there are at COP28 are just that. What matters is going to be not only the negotiations, but the action plans, as well as now what you see increasingly, which is the agreements of the willing, where sets of countries come together to say, we collaboratively agree that we support this particular technology. That, I hope, is what's going to happen at COP28 as well, as just being visible. For those who go away with that, then beyond talking to the organizations I mentioned, I think it's important that they form partnerships with companies that have got experience in this. There is that great learning already there. There is that expertise that is already there. And I think from that, what they'll be able to get is the transfer of technology, the transfer of knowledge and that knowledge base. And from that, they will be able to repeat the successes of others rather than making their first own mistakes.
Thank you. I think what I took away from that, it's time to stop getting ready to get ready and time to start delivering.
Yep.
And I think part of this is, have the current nuclear countries really embraced the fact that they need to be ready to help the new entrants? That might be an opportunity as well. So with that context, Doug, have you got anything you want to add for the good of the cause?
Well, yeah, I agree that COP28 is, I think, will have a totally different tenor for nuclear than in the past. But I think this is already happening. I mean, I sit here at NEI, and just over the last few weeks, we have had Indonesia, Ghana, Czech Republic, Armenia, just probably a dozen countries come in for trade missions where we put together our members that are the suppliers of nuclear technologies and their delegations to talk about the lessons learned here in the United States, what the options are, create those relationships. And I totally agree with Jonathan that organizations like WNA and NEI are a great place for customers and countries to get introduced to the right folks, and then create those relationships that will allow them to learn the lessons to be able to move forward. But it's already happening. It's unbelievable the pace at which we are engaging globally on this technology. And I mean, if we did a trade mission like that once every 2 years, 5 years ago, it would have been notable. But it's happening like 2 a week or 2 a day sometimes here in our offices in DC. So it's a great time and a good opportunity for these developing countries to learn from the existing operators.
Thanks, Doug. As I said, the most exciting time I can remember in the industry. It's quite a change from the depressing days of a decade ago. So, Diane, I'll leave the final kind of words to you.
Thank you. Thank you very much. And yeah, I mean, turning to COP28, we at the NEA are increasing our presence there, building up from COP26 and COP27. We agree there's a great deal of momentum. It's an important COP. It's an important COP for nuclear because it happens against the backdrop of very successful Baraka projects. where we can show the world, and the UAE can help show the world what it takes to be a new entrant to nuclear and how to deliver on time, on budget. We are bringing two main messages to COP. One of them is around SMR and advanced nuclear. We will be launching the NEA initiative on accelerating SMRs for net zero there with partners from government and private sector, because it really is about international strategic collaborations, public-private, that's going to help deliver this. We're also bringing our SMR dashboard, which is a new product from NEA this year that shows really graphically. I was going to hold one up, but we'll put it in the chat later for the NEA SMR dashboard. Shows to a non-nuclear, non-technical audience what is the status of SMR deployment around the world. I monitored the chat a little bit as it was going, and people were asking, is fusion going to happen before SMRs? I mean, I'm super gung-ho about fusion, but SMRs have already happened, with SMRs deployed in Russia and China on land and on water. They're happening in North America. They're going to happen in Europe. And then they're going to happen around the world. So our SMR dashboard, and then the other topic that we're bringing to COP, and this goes to your question here, is the importance of unlocking financing envelopes for nuclear new build and for SMR. And this, so, we know that net zero needs nuclear. Therefore, nuclear needs access to climate finance, to green finance, to ESG, and that's a really important message. Now, we're taking steps to try and break open that conversation, because, of course, how to finance the energy transition is a big topic at the COP conferences. But it's going to take more than just the supplier side, the exporting countries that want access, to be able to support their sales. It's going to take the demand side, the new countries, countries like the ones that were named by colleagues here today, coming to the table to these finance events and to these finance communities and saying, we need access to finance. SMR is the right solution. We've done the analysis of the technologies. We're doing maximum wind. We're doing maximum solar. We're doing hydro where we have hydro. And now we have a gap. There's still a gap. Even if you have a renewables first strategy, there is still a gap. And SMRs are the right solution for us. Therefore, we need to unlock financing. So we need embarking countries to join us in that conversation about financing. And then the last thing I would just say is, if an embarking country, needs to sort of figure out what the first step to take is, the 4 organizations represented here today, EPRI, NEA, WNA, NEI, all great starting points for that conversation to make the introductions and get kind of a little bit of background information and get started. Thank you.
Well, Diane, thank you very much for those really roundup comments, which brings the whole thing home. And as I look here, we've got like 40 seconds. So typical nuclear, sticking to schedule, delivering on time. I want to thank the panelists. Each of you done a great job. The takeaways really are: nuclear needs to be part of the solution. Not the only thing, part of the solution. Nuclear is mobilizing to actually be part of the solution. And there's a whole network of organizations ready to help people along the way, crash through the issues, understand the challenges, understand the lessons going forward. This is the time for the nuclear industry to actually deliver. And we're all looking forward to COP28 and the excitement will come out of there. And with that, we've hit noon Eastern time, the end of the WebEx. I want to thank the participants, thank the panelists one more time, and also thank the EPRI team in the background who pulled this together and actually facilitated it all. So with that, everyone, I hope you have a good rest of your day, wherever you may be, and thank you for joining us.